Hi, it's Art from SENKO, and I'm standing here in front of the SENKO booth at ECOC 2025 with Chris McCormick from Marvell, Director of Product Marketing, right?
That's right.
Nice to meet you, Chris.
You as well.
Yes. So, Chris, what were the key drivers behind Marvell and SENKO's partnership for this project?
Yeah, so for co-packaged optics, we really need to design things from a system standpoint, not just a component standpoint. Okay. And so SENKO being a leader in connectors and Marvell being a leader in light engines and various other semiconductors, we found this was a good partnership to look at things more systematically.
So Chris, can you walk us through the integration of SENKO's 32 PIC connector with Marvell's XPU architecture?
Yeah, sure. So what we're showing here is a concept of an XPU CPO application. So here, this represents the XPU in the system. And then after that, we have 4 Marvell light engines that do the electrical to optical conversion. It's based on silicon photonics, and each one of those is 32 channels of 224 gig. And then after that, we have the PIC connector, which brings the light out of the optical engine and onto the fiber. And then we can route that however we want for the rest of the system.
Oh, wow. So Chris, can you share any insights on how this partnership aligns with Marvell's long-term roadmap for AI and data center technologies?
Yeah, so this is enabling the co-packaged optics that the industry is expecting to be needed in next generation systems as the data rates increase and as the amount of GPUs in a single pod continue to scale eventually beyond the rack. Co-packaged optics is going to be a necessity. And so the system design here and the co-design is what's going to enable that and bring trust and reliability to these solutions.
Okay. When this is plugged into a real life scenario, how does this work exactly?
Yeah, so in this kind of represents a compute tray. And what we're seeing here is representing 4 XPUs, each one supporting about 25 terabits per second of data.
Okay.
For those, the whole tray is about 100 terabits of data.
Wow.
You might see 10 or up to 18 of these in a single rack. Each of these is about 1,000 fibers. And so you imagine if you have 18 of these in a single rack, the amount of fiber managed both within the tray and then within the rack is incredible.
You gotta love density, right? Well, Chris, I appreciate the time and thank you for joining us. Art and Chris from ECOC 2025. Thanks for watching.
Thank you.